very good day to all of you. Today I'm going to show the surface area as double integral. Okay, I am K.G.Tay from Faculty of Electrical and Electronic Engineering, FKEE of Universiti Hussein, Malaysia. Surface area as double integral. Assume that the function fxy has a continuous partial derivative fx and fy in a region R of the xy plane. Then the portion of the surface, z equal to fxy that lies over region R as surface area S is equal to double integral square root fx squared plus fy squared plus 1 dA over region R. For example 1, find the surface area of the portion of the plane x plus y plus z equal to 1 that lie in the first octant where x greater than equal to 0, y greater than equal to 0 and z greater than equal to 0. Before we find the surface area, it's better that we sketch K away. It's a surface Z here. It's actually the tetrahedron. You sketch your H2D. This is the X, Y, Z. We get x, y, z intercept are 1 by to get the x-intercept you let y, z 0, that's why you get x equal to 1. To get y-intercept you let x and z 0, that's why you get y equal to 1. To get the z-intercept you let x and y 0, that's why you get z equal to 1. So we would like to find the surface area of this tetrahedron in the first octant. And then the region R. The region R is actually on xy plane. Okay, so this is 1, this is 1, this is y, this is your x. So this is the region R. To get region R is actually on xy plane z equal to 0. That's why you have this, actually this equation is x plus y equal to 1 or y equal to 1 minus x. Okay, and then from the tetrahedron equations here, we make up z is actually 1 minus x minus y. Okay. Since z is actually equal to f, okay, z is a function of fxy, that's why fx equal to zx, okay, fy equal to z0. So here, without zx is actually differentiate respect to x. In this case, you get negative 1. Zy also negative 1. That's why it finds 1 plus zx squared plus zy squared. Okay, this one we will get Z3. Because you have the surface area. Okay, it's double integral over region R. Okay, it's f equal to z, so 1 plus zx squared plus zy squared dA. Okay, so that's why so the surface area in this case, okay, the square root 1 plus zx squared plus zy squared, we get Z3. Okay, and then this is dA over region R. Region R is a triangular, and okay, I will use vertical bar to find the region R. Region R here. So if I use vertical bar, then dA I will use dy dx. So Z3 dy dx. Okay, or actually without using double integral, okay, actually quickly factor out Z3 Okay. This is area of region R here. Area of region R is actually in here. This is a triangle where the length is 1, width is 1, which is actually we will get half. That's why the surface area in this case is 3/2. Quickly, no need to use a double integral. As we know, okay, this double constant we factor out. The double integral dA over region R actually represent the area of this region R. In this case, is then you don't need to use a double integral. Just use the area of a triangle is half of the length. Okay, half of a length plus a width. So half of 1 times 1, half of a length times the width, so you get the half. So the answer for this case is 3/2. Second example, find the surface area of the portion of the plane z equal to 2 minus x minus y that lie above the circle x squared plus y squared less than or equal to 1 in the first octant. Okay, similarly, okay, compared to just now. Just now is z equal to 1 minus x minus y. Now is z equal to 2 minus x minus y. So only the intercept x, y, z is at the point, okay, point 2. So mean here, solution, if we go to sketch, now this is 2, this is 2, this is 2. This is the x, this is y, this is z. What's here? When you let x, y 0, so z is 2. We put back x plus y plus z equal to 2. When y and z 0, x is 2. Okay, when x and z 0, y is 2. Okay, compared to the first example just now, we find the whole, the surface area actually just now represent the whole slanting triangle. But in this case, we want to find the portion of the plane z equal to 2 minus x minus y that lie above the circle. Okay, we want here, this is a circle, this is 1, this is 1. So the area that we find is actually this part only. Compared to the first example, you find the whole slanting triangle here. But in this case, is portion of this plane z equal to 2 minus x minus y that in the first octant, and the projections of region R is actually circle. So region R is actually circle x squared plus y squared equal to 1. This is y, this is the x, this is the region R. That's why this is only part of the areas. And then we find from here, we find zx is -1, zy -1. So square root 1 plus zx squared plus zy squared, we have 3. Let's see, this is whether I write zx squared, zy squared, 3. And then the surface area. This surface area is given by double integral. Okay, this one 1 plus zx squared plus zy squared, where we obtain is 3 dA over region R. Okay, now the region R is triangle. It's a triangle. The first example is triangle. This case is a circular region. Then we use polar coordinate, where x squared plus y squared change it to r squared equal to 1 or r equal to 1. R is always R is a radius, so minimum is 0. R is all positive number, that's why minimum 0 up to positive 1. And then this is only at the first quadrant only, first octant. So in 2D is the first quadrant. So theta, okay, we turn it here. From x positive up to y positive is only pi over 2. That's why this example we use polar coordinate to evaluate it. Theta from 0 up to pi over 2. R from 0 up to 1. And then sub-3. Okay, from Cartesian coordinate change to polar coordinate, dA become R, dr, d theta. Then we just evaluate this double integral in polar coordinate. Okay, polar coordinate. Okay, or actually, you can skip this polar coordinate because, okay, but you can later on double check using the polar coordinate, you should get, okay, the same answer. Here, okay, same with, okay, example 1. I can skip to evaluate the double integral using polar coordinate. So I factor out sub-3 here. Okay. This is area, okay, of region R. Okay, and then I evaluate this area of region R using the circle formula. We have a, okay, circle formula. Say circle, we have pi, the radius is 1, so pi 1 squared. This is, okay, quadrant of circle, so divide by 4. So that's why the answer is sub-3 pi divided by 4. Sub-3 pi divided by 4. Okay, this one no need to use K double integral in polar coordinate because we know this is the area of region R, which is given by pi over 4. Okay, but if you want to use double integral, also can. The same, okay, example 1, if you want to double check or practice your double integral, then you can try to verify it. Okay, if you want to use double integral in polar coordinate, theta from 0 to pi over 2, okay, r from 0 to 1, dA become r dr d theta. So we have r squared, integrate r dr, r squared over 2, 0 to 1, theta. Okay, factor out half here, so sub-3 over 2, integrate 0 to pi over 2. Okay, I substitute into r, this one I have 1, theta. So sub-3 over 2. Integrate 1, we have theta, put out the limit from 0 to pi over 2. That's why you get sub-3 over 2 pi over 2. So actually the area, because I factor out half, so the area is of the quadrant of circle is actually pi over 4. So you get sub-3 pi over 4. So same thing with the first example. Okay, you can go to double check using double integral. You can see. If you want to double check, okay, this area using our double integral, here as I have sub-3, okay, I will use dy dx. So dy dx, okay, y from x-axis, which is 0, up to this case, linear equation, y equal to 1 minus x. So x, later on we sum up the vertical bar from y-axis, which is x0 up to x equal to 1. Evaluate it. So this one we have integrate 1 respect to y, you have y. So plug in the limit from 0 up to 1 minus x dx. So 1 minus x dx. This is 3 over 2. Because it limited space. So here still carry integral from 0 to 1, 1 minus x dx from 0 to 1. So you have 3. Integrate 1, you have x. Integrate x, you have x squared over 2. Limit from 0 to 1. So if plug in upper limit, you have 1 minus half. Substitute lower limit, everything is 0. So 1 minus half is half, 3 over 2. Okay, it is true that the area of this region R using triangle formula is half. Here, straight away using here. So, okay, the area of region R actually you evaluate you get half. So this one, the surface area is the whole slanting triangle here. Okay, and second example is only portion. Portion, part of the slanting triangle, where the region R is actually quadrant of circle. Okay, the third one, we find the surface area of the portion of the paraboloid. We find the surface area of the portion of the paraboloid z equal 1 plus x squared plus y squared that lie above the circle x squared plus y squared equal to 1. I will sketch the graph on top so that you may see it. Okay, paraboloid, yeah? And this paraboloid, we have z. Z equal to 1. This one. So this is z equal 1 plus x squared plus y squared. That line above the circle means its projection. It's actually circle. Okay, what's a circle? It's a unit circle. Unit circle x squared plus y squared equal to 1. Okay, actually the paraboloid is from, okay, the range is actually z greater than equal to 1. So it is open up to positive infinity. So we are going to find portion of the paraboloid where z equal to 1 up to its projection is actually you get a unit circle x squared plus y squared equal to 1. Up to here. We may open up, but we just find up to here where its projection is a, this is 1, this is 1, this one is 1, this is the x. This is your region R. Okay, so from z we find zx, yeah, 2x, zy, 2y. Okay, and then so your surface area given by double integral over region R 1 plus zx squared plus zy squared dA. So this case the region R is a circle, so we'll use a polar coordinate to solve it. So, and then your 1 plus zx squared plus zy squared. In this case, you have 1 plus 4x squared. Squared here, 4x squared plus 4y squared. So which is 1 plus 4 x squared plus y squared, which is 1 plus 4r squared. This will be 1 plus 4r squared. So dA is r, dr, d theta. So r in this case is 0 to 1. Okay, it's a full circle, or they didn't say it in the first octant. So it's a full circle theta from 0 to 2 pi. So we just evaluate this double integral in polar coordinate. Okay, and if you have difficulty or you forgot how to integrate this one, as I said, you can use your scientific calculator. Scientific calculator. My screen. Manually. So here, this part I erased it. Okay, now to evaluate this integral, you use a substitution technique. U equal to 1 plus 4r squared. So du is 8r dr. So you notice r dr will be the du divided by 8. It's r dr. Okay. So the integral square root 1 plus 4r squared r dr become 1 plus 4r squared is a u, so squared is power half, r dr is du divided by 8. So now you integrate u power 1 over 8, u power half du, so you have 1 over 8. Okay, integration, power increased by 1, so u power 3 over 2, okay, divided by the increased power. So you simplify it, 2, 4, so you get u power 3 over 2 divided by 12, 4 times 3, 12. Okay, so now you put back the u exactly what? 1 plus 4r squared. So power 3 over 2 divided by 12. So the integral of square root 1 plus 4r squared r dr. So you notice I didn't put out the limit. No? So if you change here to u, but I didn't change the limit, so I have to replace back everything in r. So I have 1 over 12, so 1 over 12 here. So this is 1 plus 4r squared power 3 over 2, limit from 0 to 1, so left d theta. Okay, so plug in the upper limit. You plug in the upper limit. So 1 over 12, integrate 0 to 2 pi. Okay, put up upper limit. So when you put up here, so we have 5 power 3 over 2. Okay, minus, when you put out lower limit, so minus, this is 0, so minus 1 d theta. Okay, so we have to erase this one. So we have 1 over 12. Okay. Then 5 power 3 over 2 minus 1. Okay. Integrate 0 to 2 pi d theta. Okay. This one will have 1 over 12. And this will become 5 sub 5 minus 1. Okay. This part will get theta 0 to 2 pi. So will be 2 pi over 12 times 5 sub 5 minus 1. So this is pi over 6 multiplied 5 sub 5 minus 1. Okay, 5 times here, 5 power 3 over 2 is actually we have sub 5 sub 5 sub 5. Also, we can put up 5 power half. 5 power half is sub 5, so 3 times. That's why you got 5 sub 5. So the last answer is pi over 6 times 5 sub 5 minus 1. Okay, actually, you can use a scientific calculator to evaluate the inner integral because your limit is 0 to 1. Okay, of course, your scientific calculator, you don't have the r variable, you have to change the r to x. Then you get the inner result. Lastly, you multiply by 2 pi. Of course, you wouldn't get a nice answer like this, but it will be in 13 point. Here, I couldn't get out. Later on, when I finish, I will go back to show you using scientific calculator. Okay, the fourth one. Find the surface area of the portion of the paraboloid z equal to x squared plus y squared that lie under the plane z equal to 4. Again, paraboloid, but now the paraboloid, the minimum point at z equal to 0 under the plane z equal to 4. Okay, this question, your paraboloid now, compared to example 3, the paraboloid minimum point is at z equal to 1. So now this at z equal to 0, because z equal to x squared plus y squared under the plane z equal to 4. Okay, so this is 4. So you project it. So we have a circle, projection circle on xy plane. So this is 4. So that's why you have x squared plus means z equal to 4. Because we find the paraboloid below the plane z equal to the surface area of the paraboloid below the plane z equal to 4. So you substitute 4 here, 4. So x squared plus y squared equal to 4. Your r will be 2. Then from here, from this one, you find the zx, like just now is 2x, zy is 2y, and then the square root zx squared plus zy squared plus 1. Okay, this now you get, this is 1 plus 4x squared plus 4y squared. Against the region R is circular, we use polar coordinate. So this one you have 1 plus 4r squared as in example 3 just now. Okay, and then so now put up with the formula of the surface area. It's actually double integral. Okay, the integrand is actually 1 plus zx squared plus zy squared dA over region R. Okay, region R is circular. We use polar coordinate and it's a full circle. So theta from 0 to 2 pi. Okay, R Cos x squared plus y squared equal to 4. Cos you substitute z equal to 4 here. So r is 2. R from 0 to 2. Square root 1 plus zx squared plus zy squared, you have come 1 plus 4r squared. So dA is r, dr, d theta. So again, this integral, like just now, third example, you will get what? Square root 1 plus 4r squared r dr. Same with the third example. Okay, you will have 1 plus 4r squared power r, power 3 over 2 divided by 12. Here, using substitution technique as in the example 3 just now, you get the integral here. You get the result is actually 1 plus 4r squared power 3 over 2 divided by 12, and then evaluate it from 0 to 2, so the theta. So 1 over 12. Now plug in upper limit. So 2 squared 4, 4 times 4, 16, 16 plus 1, 17. So you have 17 power 3 over 2. So when deduct with a lower limit, so we plug in 0, this one becomes 1. And then, okay, lastly, you still have this one, integrate 0 to 2 pi d theta. So 17 power 3 over 2 is actually you get 17 square root 17. As I said here, 17 3 2 is actually square root 17 times square root 17 times square root 17. Because this one is actually 17 power half and then power 3. So 17 power half is third 17. So power 3. So 3 prime. So third 17 times third 17 you get 17 times third 17. So minus 1 divided 12. Okay. This integral you have 2 pi. Simplify here, you have 17 third 17 minus 1 pi over 6. So this is a fourth example similar to third example just now. Okay, now example number 5. Okay, still okay. Space area of the portion of the paraboloid z equal 5 minus x squared minus y squared that lie above the plane z equal to 1. Okay, this one negative negative, so the paraboloid is inverted, open down to negative infinity with the maximum point is z equal to 5. So this is a paraboloid. This is pi. Okay, we are finding the surface area of this paraboloid, okay, but not touch to z equal to 0. It touch up to, let's say, we find portion. Okay, let's say this is 1. We find up to here. Okay, above the plane z equal to 1. Let's say here z1 at, okay, circle here z equal to 1. We put it here z equal to 1. So 1 equal to 5 minus x squared minus y squared. So you get this one, it will give you x squared plus y squared equal to 4. Again, r is 2. Cos. So when you project this one, you get the circle, which is actually here. So we are not finding the whole paraboloid up to z0. It's only up to z equal to 1. Okay, and just now, as we said, this one zx, we have negative 2x, zy is negative 2y. So when you have 1 plus your zx squared plus zy squared, again you get the same thing, which is 1 cos squared, so you have 1 plus 4x squared plus 4y squared, so equal to 1 plus 4r squared. So similar to example 3 and 4. And against the projection of region R is circular, we use polar coordinate. That's why x squared plus y squared change to r squared. So plug in into the surface area formula, which is a double integral over region R. Okay, the integral is actually 1 plus your zx squared plus zy squared dA. So region R is a polar coordinate, is a circular with the equation, cos it up to z equal to 1, plug in here, z1. So simplify, we get x squared plus y squared equal to 4, so R is 2, and it's full circle, so theta from 0 to 2 pi, then R is 0 to 2. So this one you have 1 plus 4r squared r dr d theta. So the same integral as in example 3 and 4 here, 3 and 4, this one, you will get this is 1 plus 4r squared power 3 over 2 divided by 12. Next. Okay. So this one, we get 1 over 12, 0 to 2 pi, 1 plus 4r squared power 3 over 2 d theta. Limit of r from 0 to 2, then 1 over 12, integrate 0 to 2 pi, plug in the upper limit 2, so this one 2 squared 4, 4 and 4, 16, 16 plus 1, so 17 power 3 over 2, plug in lower limit, so minus, this one is 1, plus 0, 1 power anything you get 1, so this is d theta. And the answer same with the example 4, okay, because the limit also 0 to 2, 0 to 2. Okay, 4 and 5 is only the inverted. Okay, example 5, your paraboloid have maximum point. Example 4 is minimum point, but their projection is same. The same circle, radius 2, that's why the answer same. Okay. So you get here 1 over 12, 17, 17 minus 1, integrate d theta 0 to 2 pi, this part you get 2 pi. You have 17 minus 1 over 12, 2 pi. So we get the same answer, 17 over 17 minus 1 pi divided by 6. Okay, I recall this so I don't know how to integrate using substitution techniques. Yeah, 3, 4, 5, the same integral actually. Here, use substitution technique where u equal to 1 plus 4r squared. du is 8r dr. So you notice r dr will be a du divided by 8 is r dr. That's why the integral sub 1 plus 4r squared r dr. Basically, you integrate u power half R dr is du divided by a. So it's 1 over a. And then integrate u power half, so become u power 3 over 2 divided 3 over 2. So this is we get u power 3 over 2 over 1. So with this back, u is actually 1 plus 4r squared, so power 3 over 2 divided by 2. Okay, this is example 5. Okay, the last example. Find the surface area of the upper hemisphere z equal sub 1 minus x squared minus y squared. So this is actually when you square up everything, this is x squared plus y squared plus z squared equal to 1. This is a unit sphere with radius 1 unit. And then the sphere you cut it at z equals 0. That's why you get upper hemisphere. So when I draw, so this is an upper hemisphere, and this is 1, this is 1. Z here also 1. And this is an x, y, z. So from here you can find the zx. So zx, okay, this is power half. You have 1 minus x squared minus y squared power half. So in differentiation, bring the power in front, so half, and then 1 minus x squared minus y squared power half will be minus 1, so become minus half. Half minus 1, so minus half. And then you have the delta x, 1 minus x squared minus y squared. Okay. Remember you ddx u power n. So n u power n minus 1 du dx. So now ddx become delta x. So delta x 1 minus x squared minus y squared, you have 2x. So this is 2. Okay. And then power negative half is actually your square root at the denominator. So you have 1 minus x squared minus y squared. So you simplify. So the zx actually x over square root 1 minus y squared. So similarly, when you do for your zy, you will get y over square root 1 minus x squared minus y squared, because zy here, change it to y, delta x become delta y, so this is 2y, so you simplify your y over square root 1 minus x squared minus y squared. Okay, and then when your zx squared up this one, we have x squared over 1 minus x squared minus y squared. Okay, zy squared. Squared up this one, we have y squared over 1 minus x squared minus y squared. X squared. Square root, you squared it, so okay, will be in cancel the square root. So, and then the square root 1 plus zx squared plus zy squared. Okay, 1 plus x squared over 1 minus x squared minus y squared plus y squared over 1 minus x squared minus y squared. Okay. So combine these three, okay, as one function, 1 we multiply by 1 minus x squared minus y squared divided by 1 minus x squared minus y squared. Okay, we have the figure here. 1 minus x squared minus y squared. 1 minus x squared minus y squared plus x squared over 1 minus x squared minus y squared plus y squared over 1 minus x squared minus y squared. simplify it. So same denominator. Can give 1 minus x squared minus y squared. So you can add up your same denominator now. So you can combine the numerator. So left one, because minus x squared plus x squared cancel, minus y squared plus y squared cancel. Okay, that's why you have 1 divided 1 minus x squared minus y squared. So factor out negative, so x squared plus y squared. So 1 divided square root 1 minus r squared. This is for the integrand. Remember, this is simplify, you get 1 over integrand, 1 over square root 1 minus r squared. And then your surface area will be double integral 1 plus zx squared plus zy squared dA. Okay, the region R, you know, we get the region R here. Region R happen when z equal 0. Okay, when z 0, z squared 0, you have what? X squared plus y squared equal to 1 or R equal to 1. So mean your region R is actually unit circle. Unit circle here. So we integrate full circle, so theta from 0 to 2 pi, r from 0 to 1, and this one we get 1 over square root 1 minus r squared. dA is r dr d theta. So this one 1 over square root 1 minus r squared. So again, using substitution technique, u equal to 1 minus r squared, du is negative 2r dr. So notice we have this term, r dr is du divided by negative 2. Okay, that's why your integral 1 over square root 1 minus r squared r dr become 1 over 1 minus r squared is u, so 1 minus u power. Okay, integral 1 over u power half, r dr is du divided by negative 2. So we have negative 1 over 2, u power half, bring up, become u power negative half du. Okay, so now you can integrate u power negative half respect to u. So for integration, power will be increased by 1. So plus 1, negative half plus 1 become u power half. So divide by the increased power half. So you get exactly 2 and 2 here cancel. So it's negative u power half. Okay, and then replace back the u is actually u as a u. U is 1 minus r squared power half. Okay. So mean the inner integral, the result here, I factor out negative. So 0 to 2 pi 1 minus r squared power half, limit of r from 0 to 1 d theta. So now plug in the upper limit in r, so 1 minus 1 0, cancel 0. Okay, so when plug in 0, minus when you plug in the lower limit is minus, so this is 0. So 1, half is 1. You get the negative, negative, positive. So you get 0 to 2 pi. Okay, the delta. Exactly, you get delta 0 to 2 pi. The answer is 2 pi. So we get the surface area of the hemisphere with units, with radius 1 unit, exactly 2 pi. Okay, actually you have the surface area for circle. Okay, actually the surface area for sphere is actually S equal to 4 pi r squared. How say I didn't write. Okay, we have the